Now we will see the relation between electric field and electric potential. Consider this charge Q. Then if I just consider this charge Q, which is going to produce the electric field around it, since it is a positive charge, the electric field is going to move away from it. Consider any one of its direction. So for example, consider the direction along this positive x-axis. Then if I want to move this test charge, which is nothing but Q0, from A to B, so obviously this Q will exert some force. That force you can find, that is Q into E, which is the force exerted by this electric field. So to move the charge from A to B, definitely you have to do the work against this force. So you have to apply the equal and opposite force. So you have to do some work, and that work done will save in the form of energy. So this work done, you can write it down, obviously, which is force into displacement. Let that displacement is nothing but dr. So the distance from this A to B is dr. Again we have seen this F is equals to Q into E. Since this force is the external force, you have to write it down that as a minus Q E into dr. So this dW is equals to minus Q E into dr. This E is also a vector quantity and dr is also a vector quantity. If now you take that dW upon Q0, for example, is equals to minus E bar dot d bar. So this one you can write it down that as a E bar dot dr bar. Again, that potential, we are saying that work done per unit charge. Since this work done is a very small, the change in potential is also very small, which is nothing but dV. So dV is equals to minus of E bar dot dr bar. So in short, you can write it down this as a E is equals to minus dV by dr. That is also, we are going to call it as a potential gradient. This potential gradient means rate of change of potential with respective distance, and its direction is opposite to that of your electric field. So obviously now you can say that there is the direction is opposite. So you can say that the potential at point B is greater as compared to the potential at point A. Further, you can write it down, this dV is equals to minus E into dr. If you consider the potential between the 2 points, then it is the integration from V1 to V2, and that is minus integration of your E into dr. So you can just take the position vector from R1 to R2, and this change in potential is from V1 to V2. So if you assume that R1 is equals to infinity, where obviously your potential is also 0, so definitely you can write it down this as a V, and that V you can just write it down, that is nothing but V2. And again you can say that which infinity from up to the R, E into dr. So again you can just say that this V2 is your function of your minus E of R. So this is also one thing you can say that about your potential. So this is how you can find the relation between the electric field and electric potential.